Hello everyone. Today I'm going to discuss blade grind and edge geometry, the primary grind and the edge. A lot of people get these two confused when they're talking about sharpness of knives and how to sharpen knives. The primary grind is the grind from is the entire flat of the blade. That's the primary grind. The edge, you can have a secondary bevel, you can have a zero edge, which is on a lot of Scandis and convex grinds. But this is what I want to talk about, the geometry of it, the actual thickness of the grind and thickness behind the edge, and the type of edge that are on different knives and why some work and some don't. When you talk about the primary grind, the area that's important is right behind the edge, about 3/16 to 1/4 inch. And usually what I do, depending on the size knife, I have specifications that I go by when I'm grinding a knife. On a small knife like the PSK, I take the calipers and I have a mark on it, and I will measure right behind the edge. It's probably about 3/16, close to 1/4 inch, right behind the edge like that. And on a small knife like the PSK or the UNK, usually anything from 5 inches down to 2.5, which is what these are. I try to get to about 45 thousandths, between 45 and 50 thousandths. 45 is really ideal. Now on the larger knives, like the Tusker or anything 6 inches and above, I usually will go, 6 to 7 inches, I try to hit around 50 thousandths. Getting into the bigger knives that are really going to get a lot of hard use, 55 thousandths to 60 thousandths. Usually I try to get in that 50 to 55 thousandths range as my maximum thickness behind the edge. Now when you get to the actual edge, I don't do a zero edge, because the problem with zero edge is there's a fine line when you're doing a zero edge on a knife, where you can go too thin or you can go too thick. If you go too thin, you're going to have a feather edge. It's going to fail on you. It's going to crush. It's going to break off. It's going to roll. It's going to do a lot of things you don't want it to do. So that's one reason why I like the micro bevel. And in order to do a proper secondary bevel on the edge, you have to grind it down to almost a zero edge. So it's probably going to be difficult to see on camera, but this is a PSK that is not, the grind is not finished on it. I have to clean it up and bring it down to those specifications I just said, which is 45 thousandths behind the edge. Now on the very edge, when you look at the knife like this, from the point down, and you're looking down the edge, what you need to do is you can see it's like a black line because it's thick there. You have to grind that to where you don't see that black line. In other words, it's almost an edge actually put on it, but it isn't sharp. So when you're looking down the edge like this, you can't see that black line. That black line disappears. Then what I do is I'll go over and I'll add that micro bevel on the rotary plat. Bring the burr up, and you can see it's a very, very, very small secondary bevel. And then once that's on, and then you clean it up and finish sharpening like I do on the belt grinder, then you have a good thin edge, but you still have the stability of the secondary bevel. So that's how I do it, and one of the reasons why a lot of guys have a tough time resharpening knives is because whether it's a factory knife, a knife maker did the knife or whatever, they're not taking that down thin enough. Like I just said, where you look down, they're not bringing that down thin enough. It's thick here, and then what they're doing is they're putting their cutting edge on it with it too thick. Then when the person goes to sharpen it, they have a difficult time because it's too thick at the very edge. It's also, once you sharpen that down, you're getting into some thicker steel here, and it literally needs to be reground in order to be able to keep that edge up and be able to resharpen it properly. Now, my method of sharpening that I've done in the other two videos works with this type of edge that I put on my knife, but you can also sharpen conventionally on a regular stone. This is an older discontinued kit by Gerber, field sharpening kit, and it has the flat steel like I talked about in the other videos, and it also has a two-sided stone. Now this particular stone is coarse on this side, which is unusual. You would think it would be on this side, but it's coarse up here, and then it's a finer grit on this side. And you can sharpen, if you want to if you have a regular stone that's this way that you would sharpen on the flat, you can do it that way. But this particular stone, it's the same thing as my other method of sharpening, only you're moving the knife instead of the sharpener. You just do it like you would conventionally sharpen on a stone. You just lay the edge where you just want to hit the cutting edge. Very light pressure. I can't stress that enough. You have to use light pressure. If you're pushing too hard, you're defeating the purpose of what you're doing. You have to use light pressure in order for this to work right, because you don't want to go down too far. You don't want to go up too high. If you go up too high, you're going to round it. If you go down too far, you're not even going to hit the edge. So light pressure is the key, and you can feel what you're doing when you're using light pressure. So you just go away from the edge and go down like that. Do it slow. Take your time. There's no rush. And do the other side. Same way. Light pressure. You can do it if you want to. 1, 2, 3, and then flip it over and do the same thing. 1, 2, 3. But again, light pressure. You don't want to push too hard because you're not going to get anywhere by doing that. Then to finish it off, this steel, it's hard to hold it and do it that way, so I do it the way I did in the other two videos. I just hold it up like this, very, very lightly, just go along the edge. 2, 3, like that. Flip it over, same thing. And if the geometry is right on the knife, if it's not too thick, you shouldn't have any problem keeping your knives sharp. The important thing is don't let them get dull in the first place, because then you're going to have a job getting them back. One other test that I do to see if the geometry is right on a knife is doing the wood curls. And you know, with that, hopefully you can see, if you can get decent curls like this, you got good geometry. If it's not a real big effort, then you got good geometry on it. And I also want to point out that there's too much stress put on shaving sharpness. Just because a knife doesn't shave hair off your arm doesn't mean it's not going to cut well. A lot of people are anal about that. I am to a point where I like to, you know, I don't have any hair on my arm because I'm constantly testing. This UNK, I hand sharpen. It's not really shaving hair readily. If you push hard, you can get some hair off. But even though it's not sharp, it's still got decent geometry on it. You can still get the curls off. You know, it's still going to go into the wood. I guess you can see that. It might not be as effective, but it does do the job. You can get them off. You can see that. Now, getting back to measuring with the calipers and the edge. Scandi grinds are known for their razor sharpness and their ability to carve well. They have a very, very short primary grind like it's on this Mora. It's very short. Now, if you were to measure, and it's very thin stock. I mean, that's almost a 16th, a little more than a 16th of an inch. I don't know what the exact thickness is on these, but it's very thin blade, very short grind. But if you were to measure like I just discussed in measuring, if you were to measure this Mora behind the edge, it is almost 60 thousandths of an inch, which is quite thick behind the cutting edge. It's almost all the way up to the top of the grind, but it's about 60 thousandths behind the edge, which that's what I usually put on a 1/4 inch thick camp knife. So the reason why these cut so well is because it is very thin at the very edge. These have a 0 edge. It's very thin. If you were to look down this and it was too thick, and then you put that cutting edge on it, it wouldn't cut well. So that's why these cut very well, because even though the primary grind is thick behind the edge, it's brought down to a 0 edge and it cuts well. Same with an axe. This Wetterlings is behind the cutting edge is about 70 thousandths. Now, when you're getting into chopping tools like an axe or a big camp knife, in order for it to hold up to heavy pounding and heavy chopping, heavy batoning, you want meat behind that edge. Now with the Wetterlings, there's a 0 edge on this, just like most axes have. It's a convex grind with a 0 edge. The problem is, a lot of times, if there's a 0 edge on an axe, these aren't hardened very high. They're softer in order to handle the impact, because it's an impact tool. So you're going to end up with dings and rolls and chips and things like that along the edge. If you put that micro bevel on it by hand, you're not going to have that problem. So that's a lot of it. Like I say, with the edges, if they're too fine, too thin, they're going to be a problem. So I hope this explains a little bit about geometry and helps people out with when they're sharpening and when they're picking out a knife and they can't get it sharp and they're wondering why. It's probably because of the geometry that the grind has and the edge has. It's a very, very fine line between being too thin and being too thick. So I hope you enjoyed this explanation of geometry. I hope it helped you out, and this is the way I do it, and it seems to be working. I've worked on this geometry thing for quite a few years trying to get it right. So until the next time, fellas, have a good time in the field and be safe out there.